So, like was just mentioned, I'm Ben Hayak. I'm in the security industry almost for like 10 years now. I was doing consulting and some reverse engineering, then a lot of web. And I'm going to present the same origin method execution attack, which is something that I presented about in Black Hat 2 years ago. But there was a lot of confusion about the attack, and I really wanted to clarify things. And to be honest, I didn't have the chance to actually talk about the technical details in the conference before, because I really wanted to tell the people about the implications of the attack, and because it was fairly new. So the title says advanced aspects. However, I'm not going to cover all the advanced aspects of the attack because of the time frame, but it's going to be enough, and if you need more than that, make sure to read the white paper, and it will be more detailed than this. Same origin method execution is something between CSRF attacks and XSS. It's worse than a CSRF, but it's a little bit less than an XSS, but it can get as worse as it is. So it's a client-side web application attack that you attack a browser, you hijack operations on behalf of users. One of the problems that disturbed the attack to be like very popular is because it's less prevalent than cross-site scripting, where in cross-site scripting just like filtering or you don't sanitize input, you have the attack. Here you have to find dedicated endpoints. So the popularity, let's talk about how prevalent it is. So the first time I saw the attack, I saw it on Google+. I just want to mention that everything that you see here is patched already. That's like PR things. But the Google Plus had a dedicated endpoint that executed a callback function. And callback function is simply a JavaScript function that executes in that endpoint. So they were vulnerable. Yammer, which was found by a researcher, another researcher, Flash endpoint. WordPress, every WordPress before this version that you see on the screen was vulnerable by default to some, and there is a lot you can do with that, including adding yourself as an admin on behalf of a user if you're attacking another admin. PayPal, I reported a Flash endpoint to PayPal. Salesforce, which I work for right now, so everything is patched in Salesforce, don't worry. But we had documents and other private bug bounties. It's categorized as some. Everybody knows about, not everybody, but bug bounties know how to respect that and pay for it accordingly if you find it. So what is same origin method execution? I want to clarify this because there's a lot of confusion about JSONP and the relationship with that. The same origin method execution is the ability of arbitrary method execution in a web application context. Whether the endpoints may be plugin systems or documents like dedicated pop-ups or stuff like that, the attack starts by having the ability to execute a method on a web application context. And you'll see later why it's important. So I like to explain what I talk about, and let's see, at the start I'm going to show you a demo of what I mean by arbitrary method execution. And arbitrary is basically having the ability of controlling which function is being executed. So I built this playgrounds for you to realize what it is. And this is just like ordinary behavior in a web application context. This is a pop-up window that opens once you click here. And whenever you click this color wheel, you see the color changes on a different context. So the pop-up do this by, let's see if I can zoom in, by this callback parameter is being equal to change color, which is a JavaScript function on the main window over here. So basically, if we take this and open it in a new window so you can see what I mean, zoom in a little bit, and you can see this error, the change color, this endpoint is trying to execute an arbitrary method. If I say execute this method, for example, you will see another error, and this error is good for you. I mean, this means that there is an execution that you control in a web application context. This is an empty context. There's nothing you can do with this, but at least you have, this is the starting point for some. If you find this and learn the attack, you can do a lot of stuff on behalf of users. So callback, the concept of callback is not cross-site scripting, so it's limited. So if you insert some special characters in here, then let me clear the console so you can see it more clearly. But if you insert anything that is considered not callback friendly, which is not alphanumeric dot and an underscore, you would see there's no execution, hence there's no error. So that is what I mean by arbitrary method execution, where you control this value over here, and endpoint try to execute methods, but with a limited character set. Let me bring the clicker again. Okay. So yeah, so like I just showed you, callbacks limited to alphanumeric characters, a dot and an underscore, because developers believe that this is going to protect them from web application attacks. And otherwise, it will be a cross-site scripting because you can just break the context and inject JavaScript. But even though there's a limited character set, we always do very cool stuff, and we can do a lot of stuff with even with a limited character set. So that is important to understand. So you may believe like that, okay, you saw that there is an arbitrary method execution. You can already execute JavaScript, even though it's a limited JavaScript, so why do we need the sum attack, the same origin method execution attack? And the answer is because sum allows you to bypass 3 obstacles. First of all, like you've seen, there was like a color wheel in that. Let me show you that again. Never mind, let's just see it. So you had like a page which only had like an empty DOM. It had like a color picker and nothing meaningful. It didn't have like add yourself as an admin or anything useful that you can do on behalf of users. So the execution context of which the JavaScript executes that is useless. You can't do anything. With the sum attack, we select a target, we select another URL, and I'll show you how to do that. And we designate the execution, so we move the execution to that endpoint. So instead of executing in the empty DOM, it will execute on something that we want and something that have meaningful operations on. So this is one obstacle. The second one is wrong timing. I mean, the executing callback endpoints usually executes right away. As soon as the page loads, it executes, and we need to make sure the execution takes place at the right time. So timing is a problem. You understand that a little bit later on, more in depth. And a limited character set, like we mentioned, there's only alphanumeric characters, a dot. So we'll call this from now on, we'll call back callback-friendly character sets. So you understand that I mean alphanumeric, a dot and an underscore. So with some, we only use that as a payload, and we can still do a lot of stuff on behalf of users. So if you know about cross-site scripting, you would know that cross-site scripting, for many people, is just an alert box. But for people that want to do something real on behalf of a user, they build a payload, they do something, they first select a target, they first trigger something that they want to do on behalf of users, they build a payload, which is planning, and then they execute. So in a SAM attack, it's the same process. You have to work through targeting, planning, and then executing. And what is targeting? Once again, I want to show what I mean by targeting. You simply select anything that you want to target. If you have the SAM attack, let's see where the video plays at. Oh, let me drag it. Okay, so targeting, in order to understand targeting, it's kind of simple. Let's say you have this e-commerce website, and you know there's an admin or some platform that you want to attack, and you know that the admin is running this platform. So you install the platform on your computer, on your local host, or whatever you want, and you start exploring the target. Let's see, like if you want to go to, for example, sales, you want to go to orders, and select some order of $2,000, for example, view it. You just explore the website and decide, like in a CSRF attack, you decide what you want to do on behalf of a user. So at this point, we decided that we want to cancel this order on behalf of a user. We don't have XSS. We have a same origin method execution, arbitrary method execution that you've seen. and we want to cancel the order on behalf of the user. So what we do is we save the URL, because we want to target this URL, and we want to save that for later on. So we copy that, and we select the target, which is the yes button over here of canceling an order. This is just an example. It can go more severe or less severe, depending on the website. And luckily for us, if we inspect this button, we see there's an ID that we can use to reference this button using JavaScript. However, this ID contains hyphens, and hyphens in JavaScript is right here. So hyphens will be considered as arithmetic operations, so we can't really use this ID. We'll need to use something else to trigger this yes button. But the most important thing to understand here is that this is targeting. We select what you do, very similar to what we do in a CSRF attack. Okay, so the next thing is, after we selected our target, we go to this planning step. So planning is really, really simple. It's shuffling the cards right or whatever. You just simply open another window in your website. This is all there is to understand in a planning website. So we just use the simple window.open operation in JavaScript, and then you have another window. It does some magic. You will see later on why it's important, but the basic thing is that now, instead of one window object, we have two window objects, and we can play with the execution context, and that will be really helpful later on. So the last step is execute. And like you've seen, we had in a color picker or any other website, we had the ability to execute arbitrary method, which is the starting point. So after we target and plan, we use a set of redirections. I'll show exactly what and how to do that. But we redirect the pages in the right place at the right time in the right order, and we cause the website on the same origin to execute the JavaScript function and, on the victim's behalf, and make him add us as an admin, or if this e-commerce website example, cancel the order on behalf of him, because he has the permissions to do it and we don't. So we use redirection for that. The steps would be like this. You redirect the main page, like I mentioned, we use two windows. So we redirect the main window to the target URL that we chose, the e-commerce website or whatever else. And for that, we break same origin policy. So then, after a timeout, we redirect the second window, the pop-up window that we opened, and at that point, both of the windows will be at the same origin. We set the callback parameter to a method that we want to execute on behalf of a user, and then the method execute on this context. So that is the brief overview of the attack. Now we'll go a bit more deeper to the details on why. So back to the first slide. The ability of arbitrary method execution, this is really important to understand. There was a lot of confusion because every time people see a callback parameter, they think, hey, maybe I have a SAM attack, and maybe I can get paid for this in bug bounties, or report the vulnerability to my client. But it's important to understand that what arbitrary method execution means, like I showed you in the color picker, and it can be found in two different ways. It can be found in dedicated pop-up endpoints, or it can be found in Flash plugins, which is a lot more, there's a lot more instances in Flash and other plugins that runs JavaScript to interact. So we need to understand which endpoints are vulnerable and why. The number one thing that you need to make sure is that you have an active context. The callback executes in a text HTML, text XML, whatever, or a plugin, whatever that the execution context may be. It needs to be active. It needs to be active, and it's not. For example, if you see, like I mentioned, JSONP endpoints are not vulnerable unless you can chain them. If you can make a JSONP endpoint callback execute on the page and not just render, then you have a SAM attack. But if not, then that's not it. So. Sorry for the split screen. I hope you can see it, but I really wanted to emphasize what it means. And this is how to find it. Like, if you are typing in a URL, for example, and you have a callback parameter, and you type something in the callback parameter, and you see one of these errors in the developer console, of course, you see that the developer console cannot read property vulnerable, which we just typed, or vulnerable is not defined. That means that there's an empty context, or that means execution in general. So the web application tries to execute whatever you put in the URL parameter over here. So this is good for you, even though it's an error. This is a starting point for a same origin method execution attack, and this one is a good example to finding the vulnerability instances. In opposed to that, if you have a URL and you have a callback parameter, and by the way, the callback parameter does not necessarily have to be named callback. It can be CB, ready function, onload, whatever, as long as you see the execution takes place on the website. So you type in, same thing, same process, you type in something in the callback parameter, and you see it renders the, whatever you write, it renders it to the page. That means that's not good for you. It's just like a direct access to a JSONP endpoint. The content type is passive. It's application JavaScript or application JSON. This is not execution. So unless you chain this with something, this is not vulnerable. And I really wanted to make sure people understand the differences. So yeah, okay, so where to look for same origin method execution attack. If you want to find it, if you are hunting for bugs, if you have a customer, or if you're a developer and you want to understand that, the potential, the great potential is in two different endpoints. They're like dedicated pop-up windows, mostly. If you have a website and this website have a color picker, for example, like I've shown you, or whatever else that opens a pop-up, this pop-up needs to interact with the page over here. So it needs to notify some complete event or any other event, and it needs to do this. And they may use developers may use JavaScript to do this because it's fairly simple. You'll see reasons for this in the next slide, but they can do this with using the callback parameter and type in some JavaScript functions. So this is a good place to start looking for same origin method execution vulnerabilities because this needs to interact with this somehow. It will do it with the redirection and stuff, but this is a good place to start. In opposed, once again, to this, which many people confuse about this. This is direct access to JSONP endpoints. It's not vulnerable. And yeah, so one more thing is Flash. Okay, so Flash is very popular endpoint that you can find some at. Actually, there are plugins that enable same origin method execution vulnerabilities by default. So the reason for this is, oh, you know what, the reason will be in the next slide anyway, so there's no point of telling you right now. But the basic thing that happens here, if you want to find some, once again, that was the pop-up windows that you want to check, and there is this a Flash file. So if you decompile a Flash file and you see this is actually active JavaScript execution. However, the parameter, you see loader info.parameter.ready function, this is the parameter name, the get parameter name, and this is execution, but however, they try to clean the string, and they allow only alphanumeric characters, an underscore, and a dot, which is safe for cross-site scripting, but not safe for this attack. So if you see this in a Flash file, this is a vulnerability, and this is, you no longer have to like ditch the file and leave it. You can do something with it with the SAM attack. So this is another good place to find some. Now I want to be fair with you and tell you why people do it. I mean, why would people let you execute a callback function? Why would they like give you a parameter to do this? I mean, it doesn't make sense, right? So there are reasons. There are the reasons. In order to understand the reasons, first we have to understand where. And I actually mentioned that already. But the basic two main positions for the attack are plugin systems and documents, like dedicated pop-ups, like you've seen in the previous slides. So once we understand that we have two different locations or two different types, we want to answer the question why developers make such like vulnerable endpoints documents, so like the dedicated pop-ups. One main reason is interaction, because like I said, whenever you open a pop-up, you have to interact, or any other, like a frame, a pop-up, doesn't matter, another window object, you have to interact with your main window using some callback or some other type of interaction method. So developers may use the callback because it's very simple. Let's say a web application context gives you a chat option, like Facebook. So you're chatting in Facebook, or you're chatting in any other website, or you're writing a blog post. So you're typing something, and the same website gives you the ability to do something in parallel, like choosing a color or anything like that. So they don't want to redirect you to the other page to choose the color or to do that stuff. They want to do it in parallel, so without like deleting everything that you did in the chat box or the blog post. Even though there is caching, but they just don't want to break the operation that you're just doing. Same for OAuth. If you're using a website and you want to like get a resource from another service, like reporting context or whatever, so they would rather use a pop-up for login with rather than other stuff, because that would not ruin the website, the things that you work, the content that you're working on in the website itself. One of the most important reasons, it's very, very simple. Like, it's very simple comparing to the alternatives like course or post message in HTML5 that you have to secure the channel and all that. So you just like simply execute a callback, then the pop-up knows, or the Flash plugin knows how to interact with the other window. So the same question goes for vulnerable plugins like Flash. Once again, it's the conventional cross-context communication way. A Flash, I assume most of you know already that a Flash file is another context. It's another context, like if you're embedding a Flash file in a web application, it's another context, so whenever the Flash wants to interact with the page itself, it needs to execute some JavaScript and tell it, like, notify events and stuff like that. So the DOM knows how to react. So the question is, why did they give us the ability to control the callback? I mean, I explained the interaction, but why not setting a static value that says, every time I'm ready, execute a static name function? And that will solve everything, but why would they give us the ability to control using a parameter or whatever? And one answer is that they serve a large scale of users. Let's say that I'm a developer and I'm making a video player, for example, and I want many, many websites to use my video player. So I don't want to force, like, I don't know, like example.com to execute a static name, because maybe they use event-driven JavaScript or any other technique, so they need to execute functions using like object, dot something, etc., etc. I don't want to obligate them, so I give them the opportunity to choose their own way to execute callbacks. One example is once a Flash file is embedded in a website, it needs, like, if it's a very large Flash and it supports interaction with HTML page, let's say like a play button or whatever, it needs to tell it, the embedding document, okay, I'm ready, you can start interacting with me. So that will be an example in the Flash plugin. And above all others, right, the callback, the developers know that in order to prevent cross-site scripting attack, they need to sanitize characters. That was always pushed by security guys like me that say, okay, sanitize input and then you're safe from cross-site scripting. So they rely on this rule. This is a regex that limits the whitelist only characters and a dot and an underscore, which is callback friendly characters. And they say, what can go wrong? I'm safe from cross-site scripting, so this is good enough. So these were the reasons and how to find same origin method execution. I want to break it down more and just like talk about the interesting stuff of how to assemble an attack and talk about arbitrary callback execution again. And arbitrary is basically dynamic. Don't like panic from this word. But the thing is, let's see the URL that you are, like the vulnerable instance may look like this, like you've seen in the demo, like a function that says some callback parameter that and equals change color, and the attack, the exploit would look like this. Like it would say context like opener or any other name of another window. A reference to what you want to do, like remember your target, like the cancel order button. So you can reference this button using JavaScript. We'll see in a minute how. And the method that we want to hijack on behalf of user, whether it's a click, submit, setting data, and etc. So okay, so this is what I just talked about. Like if you see this in an endpoint, you see, can you see the callback? Let me zoom in a bit. So there's a callback parameter over here in the endpoint, and you see, if you look at the source code, you see that there's an execution trying to take place with the color hash value. And we don't control this. We can only control the part here, and we still can do, can execute the attack. And you also see that this execute me name that we put in here tries to be executed, and hence we see this error, because the opener is null, and therefore there's an error. But this is arbitrary, zoom out. Okay, so this is arbitrary, callback execution. Okay, you see this endpoint, you see this pop-up window. It's not a pop-up right now because we opened it directly, but it doesn't have anything. It doesn't have anything meaningful. It doesn't have like delete all the orders in the page or do something special that you actually show impact to a customer. It's running on a domain. This is my domain, but this can be any website. But the thing is, the DOM is empty. I mean, it's nullified. There is nothing meaningful, only a color picker, a color wheel, nothing we can do to exploit this. So I call this a useless DOM because we cannot do anything meaningful. However, I mean, even though we can execute callback limited JavaScript callback functions, we don't have anything meaningful there. So we need to solve it by moving the execution context to the target that we want. Okay, so targeting is the most meaningful, and I think it's the hardest part to understand in a SOM attack, but just bear with me. I'm going to explain it really deeply and show you how to target websites. So we're going to talk about choosing the URL that you want to target, like you've seen in the e-commerce website for deleting orders, for example. We're going to talk about pinpointing a target reference, which you'll see in a minute. It's creating a string, that alphanumeric string that represent buttons or active elements or forms in the web page. We'll see a demo and a tool that I made for making it easier for everybody. Okay, so back to the e-commerce website. We said we want to target this yes button on canceling an order. So I think it's big enough so we can see this. This is how a reference may look like. This is a way using JavaScript to reference this button. Like you see, the console says, okay, this is the button, and we use document.body.first-element child, etc., 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 etc. We navigate, we go throughout the DOM tree all the way down to the button. So if we know how to do this, we can use the callback endpoint to click on this button on user's behalf. But don't worry, don't panic because of this long string. There's a lot easier way to do this. Okay, so at this point, like I said, the targeting is not very simple. So thankfully, the white paper is on, and bug bounties and also other customers already appreciate alerts. So if you can just do an empty alert or alert that gives you the color or whatever, if you can do this, this is a well enough POC that you can post and it will be accepted by your customers or other if you're a bounty hunter. But if you are looking for bugs, if you want to actually exploit bugs, if you are hunting for bugs and not bounties, or just do both, you can use DOM navigation properties. So the DOM navigation properties that I found to be really useful are these, like first element child, last element child, next element sibling, previous element sibling, and parent element. The names are pretty intuitive. You can understand what they do. Like if you have the jump tree, you can get inside the children of an element, or you can go to the next child, and etc. And also, don't forget, you can also trigger JavaScript functions on behalf of user directly. If you have a JavaScript function, let's say object.cells.deleteOrder, and you want to hijack this, you can do this with the SUM attack directly. You don't have to navigate. But if you want buttons or elements or forms, you can use the navigation properties. So a reference may look like this. So there is the context of where we want to execute. And then it will be document body. It doesn't really matter. And then it would be the submit. In this case, a form submission would look like this. So this part would represent a form on the opener window, and submit the method that we want to hijack. Or once again, a JavaScript function, once again, context, and the JavaScript function on the opener window. So it can be anything. Like a CSRF depends on the window that you are targeting. This would vary. So like we mentioned, we can travel throughout the DOM tree using navigation properties. There are two main ways to do this. We can start from the document body like you saw, but there was like a very long string, right? There was like a very long reference, and it's just messy. So we can either use document body, or we can use a div box. I mean, not a div box, an ID, like any element that is identified by an ID or a name can be referenced using directly in the dev console or using JavaScript. You can just type in divbox1, and it will right away reference this divbox. So if there is an element that is closer to your target, then it will be easier for you to use that and navigate from there on, and not start from the entire, like from the starting of the page, from the body, and go down there. So then, like I said, use navigation properties, first element child, next element child, and etc. To reach the target element, and then select the method that you want to execute. Once again, if you don't want to do these steps, you can just use an alert to prove your POC, but this is way more fun and meaningful. So I built a demo, a playground that you can practice on. I didn't do it in a demo version, so you can just click and everything works. You have to actually learn what you're doing here, but I'm going to show, obviously, in this conference how and what to do. So the target in the playground is to trigger a click on this red button without clicking in it on behalf of users. So targeting would work like this. Like I said, the step starts from targeting, then planning, and then execute. So this is the first step. So we can use, like I said, document.body.firstChild to get to the layout. But if you right-click this in Chrome and you inspect the element, you would see that there is hints over here that tells you every time you see a hash string and a hash character in a string, that means a valid ID that you can use, as long as it doesn't have like hyphens or characters that are not allowed. So you can just click on, just create the reference by this, or you can just use the ID directly without starting from the body like I showed before. So right here, a main, then would reference the main.firstElementChild would reference the header, and you go forth and forth and forth until you reach out to the button that you want. And these are just alphanumeric characters and a dot, and that's nothing special, right? So nothing suspicious, no filters would detect the attack and whatsoever. So yeah. So I'm going to show you quickly how to do this live. Okay, so we inspect the element that we want to target. Let's zoom out a little bit. So we inspect the element and we see, okay, we inspected this element, and Chrome would be kind enough to show us this is the button and this is the closest named or identified element that is close by. So if we type in main, we reach out to the main element. Let's see this here. Okay, so main element, and there's a simple trick here. Every time you see an open arrow, that means the branch for reaching the button is a child of the main div here or any other element. So what you do is main.firstElementChild. You use the first element child property to reach out to the first child of main. And then closed arrow means that you need to go to the next and not go inside the children of the next element. So we can use next element sibling to do this. So we reach out to the content, and et cetera, until we reach, like, I made it like a reference here. So basically there was like children and just like siblings. So we go five siblings down, then another children here with the open arrow. So we use next, first, blah, blah, blah. Doesn't really matter. If we type in enter here, we created alphanumeric reference to this button. So if we add in the click method, I'll add parentheses here, but in the attack we wouldn't see parentheses because there's always, they'll add them for you. But if I do this, then you will see the same simulation if the user, if I already click this button with my mouse, I can just do it with reference and that's it. So this would be a reference, and this is how to create it. But I don't want people to work hard. So what I did is I wrote a Chrome extension you can install, and that Chrome extension will allow you to basically, the Chrome extension will allow you to basically do whatever I did and more efficiently, using simply you right-click anything in any website that you want once you install it. And what it will do is it will allow you to target this element, and too much of a zoom, but it would open a box that lets you copy an alphanumeric reference to whatever you want. I can trigger whatever. If let's say if I want to trigger this and any other website actually, and we'll do this, and we'll give you the reference. So let's stick with this one. And also, I'm console logged stuff so we can use it easier. So once again, if I add the click, it will trigger the alert and hence will click on this button. It also tells you which target URL you're targeting, but it's easier to just copy the URL from here. But let's say we target this URL, and that is it. So you can use the tool. Feel free to use this tool. It's available in the Chrome store. It's easy to download and use it as you're making same origin method execution exploits. Planning is really, really simple. It's just like I told you, it's opening another window. So you can get rid of the execution that happens in the color picker window or any other empty document, because that's the nature of callbacks. And we need to understand what we have so far. So we have an empty, we have the arbitrary method execution on an empty nullified DOM that doesn't do anything meaningful, like I said, doesn't have any special buttons that we want. We have our target URL, which is the page with the red button. And we have a target reference that includes only alphanumeric characters, a dot. This could also use underscores, but at this case, we don't need them even. So we have all these. Now, for planning, we need to somehow make the context, the execution to happen on the context that is useful for us, hence our target URL, which is here. So what we do is we craft a page, evil.com, and open another pop-up to evil.com. That's it. That's the whole point of planning, using window.open simply. And what just happened because we did that? The magic here is that once we open another window, we have another context. So now we have the main window that we had, like evil.com, and now we have another pop-up, and we can play with the context. So yeah, windows can communicate using JavaScript, even though the windows are different. So we can communicate as long as same origin policy exists. What we did is we unbounded the execution from the empty document, a nullified DOM, and we created the ability to execute on a different window. And now we can use the opener, just add this string, and all of a sudden the execution will take place on another window. So that is really useful for us. And I'll once again show you quickly what I mean by that. So I built a quick demo. This is a box that whatever I type here, it's just evaled, okay? It's just executing here. So this JavaScript tells you that hello from main was executed. Main is this window. And once I open a pop-up window, sorry, okay. Once I open a pop-up window, I click execute, it says hello from win1. But both of them executed on the same page, right? This executed on the pop-up page and that executed on the main page. However, if I simply add, once again, alphanumeric, nothing special, no special characters, I add the opener context, all of a sudden I'm executing JavaScript from this window, but it triggers on this window. So this is really, really useful and very, very helpful for us. So this is execution, from win1 to the main window, for example. Okay, and once I click execute, the execution will take place here. And guess what will happen if I'll do opener.alert or any other method? It would execute on the main window, right? Even though it was triggered from this window. So that is a concept that we base on to trigger the attack. So it would look, like I said, it would look like this, opener.target reference, and we have the target reference of a button that we want to click on, and it could be a form or anything, and we have the target method, and which is, in our case, it's a click. Well, the final step is putting it all together. Like, okay, I'm going to show you how to play with new window and redirections to make the execution take place and do actually something meaningful on behalf of victims and how to do it. I'm going to show a demo, and I'm going to expose a POC generator that you don't have to learn the entire attack and how to do it. You just like use the generator and that's it. So once again, let's go over what we have. Now we have a useful method execution because we can play with the context of these windows. We can choose where we want to execute that. And that means we can execute it on something that has meaningful stuff, like add me as an admin or delete orders or whatever, like in a CSRF. It depends on the website. But now it's useful because of the simply opening another window. We have a target URL and a target reference, right? We have box.nextElementSibling, nextElementSibling. Notice how the tool made a lot shorter because it's more efficient than manually doing it, unless you're like want to spend more time on shortening. But we have the target reference, we have the target URL, we have a new window. We have one more challenge to solve, right? Because since we have in browsers we have same origin policy, we want to make sure that the target URL must be rendered in the opener context before the execution takes place. So I told you, like, once you redirect to the callback endpoint, it executes a callback. So that's not good for us. We want to make sure that it executes a callback on the opener window, on the target URL, but we want to make sure the target URL is like the rendering of it completed and the DOM is ready for execution. So we do that by redirecting, like I said, we have the main window, we have the pop-up window. What we do first is we redirect the main window to the target URL, the page with the red button, hence. And then, only after a timeout, we redirect the pop-up, because both of the pages, at the starting point, both of the pages is in our control, right? It's evil.com and evil.com. So we can control the JavaScript. So what we do is we use location or whatever method that we want. We redirect the page, the main page to the target URL, the page with the red button in our example. We redirect the pop-up to the callback to the vulnerable instance with the callback parameter set to this string over there. And therefore, the pop-up will execute a click over the main window without the user's knowledge, and therefore we hijack the operation. So we make them do stuff that they don't want to necessarily do. So this relies on the fact that in browsers, once you redirect, a lot of properties are being deleted or overwritten in the document, like document location and all that stuff, cookie and all that, but the opener reference stays in memory. Even though you redirect pages to whatever domain, like Google, Facebook, whatever you want, the opener stays. So this window, unless they explicitly delete it, the opener stays, and therefore you can reference the main window or whatever you want using the opener reference, even though you redirect it. So let's see a simulation, or actually, where's my mouse? Oh, okay. So let's see what I'm talking about. I mean, this is an exploit of putting it all together with the red button. Let's say I am attacking my victim, and I'm sending this link, okay? This would be served in any website, but for the demo, it's in my computer right now. It's simply as an HTML page, and once we convince the user to click on this link, it would open another window, and that's it. It will click on behalf of him over this button using redirections, pop-ups, and whatnot. So as you notice, the page was redirected. If you could see it, it started with a link, it redirected to this page, which we have the target button. And this window over here redirected to the vulnerable instance with the callback set to, let's see if I can zoom in, box.elements, the reference to the button on the opener window, and .click. And the reason you don't see an opener here, because this endpoint specifically already add an opener reference, but this can vary between vulnerable endpoints that you find. Let's see this again, okay? So we click here, on like the victim clicks on that, and then execution takes place on behalf of him. So you could do anything on behalf of a user once you have this. I mean, almost everything. Okay, so I wanted to, once again, simplify stuff, and for this talk, I wanted to give you the ability of not working so hard, not worry about opening another window, redirecting, making sure the timing is right, and everything. So what I did is I built a generator that basically, if you wanna create the attack, if you wanna create a POC, you can use the generator to exploit this. This is a basic generator, so people already exploited, did a lot more advanced stuff, like using, like hijacking multiple clicks or multiple actions, multiple JavaScript actions. My first POC had two actions that made me steal private photos from Google Plus instances, but the Google fixed it very well, and now it's fixed. So don't try to attack anyone. This is not the purpose of the presentation. But the basic thing is, the basic exploit generator works like this. Let's see it live. I hope you can see it, what I'm doing. So we want to work on my playground, so we don't have anything problematic here. So once I detected the arbitrary method execution right here, I know there is a sum here, okay? And you have the ability to check for a sum yourself, but once you know this, this is the vulnerable instance. So you can copy this to the generator. We don't need a callback parameter. You can put whatever you want here. So this is the vulnerable instance. Callback parameter is called callback in our case right now. The target endpoint, what we want to target. At this case, we want to target this red button, but this could be anything. So the target endpoint is playground, index.php. And here is the target reference that I talked about, the alphanumeric target reference with first element, child, and all that. If, once again, you don't care about creating a reference, you just want to send a POC, there is a possible checkbox over here that you click here, and it just sets an alert POC. But let's do the fun way and click on this button. Let's do this using the tool. Let's target this element, copy. And it created a reference to the button that we wanted. Add the method that we want, in this case a click. This gives you the ability to set how many seconds you want to wait before the rendering of the target URL happens. And this can take longer, but 3 seconds is ideal if you have a distant, if the victim has a distant connection. Then 3 seconds is enough. And then you click generate. So once you click generate, I made the HTML page that does everything for you. It does the redirections, it waits, it creates all the things that you want, the things you want to happen, the pop-up window, everything. And now you have the option either to launch a test, so you can make sure you did it right, or to download it and send it to your customer or your bug bounty program that you're triggering, if that's the point. So let's see if it works. I mean, the generator, what I did is I just pasted in stuff in 4 input boxes. I didn't even touch this, and click generate. Now I have an exploit to send to the victim, or hopefully you're responsibly disclosing stuff, so you send it to the company itself. What would happen here is automatically when I click as the victim, when I click the click to exploit link, then the entire exploit took place. We hijacked the click on the red button. Once again, the red button could be add myself as an admin or anything other than that dangerous you could do. Okay, so that was the generator. You can feel free to use it. The domain is someattack.com. You can use it and you can practice on the attack and try it in practice and see if you've mastered the skills of doing this. And you can hijack more than one operation, like I said. Okay, so time ticks. So I wouldn't be able to show you the more advanced aspects, but I'll make sure to post them on the website. There was related work that Matthias Carlsson did, and he did an amazing POC in WordPress. He made a POC that adds yourself as an admin by sending a CSRF to a CSRF protected form of adding an admin, and the CSRF fails. However, it sets data in the fields, and this data can be later on combined with some to click on the submit form. So you can set data using a CSRF and then use some to actually bypass it, because CSRF does not, like CSRF tokens does not protect against some. So I don't know any protection against some, but the ones that I'm going to show in a bit. XSS using the sum technique is something I'll post on the website. It basically, when you have control over limited control of the argument rather than the callback parameter, you can use the sum attack to set the opener reference, so it won't be null, and a lot of cool stuff. Okay, so let's talk about how to protect. Okay, the number one protection here is basically using static callbacks. Like, don't let people control the callback parameter. Don't give away a parameter for this. Many times people implement dedicated callback endpoints and they don't make a static callback. So they let you control, but they don't need to let you discontrol. They just follow some tutorial and that's it. So that will be the best protection. Another protection will be, if you can't do the first one, you may create a whitelist, so you can either accept 2 or 3 callbacks, static values, and if the server see the callback is something like first element child, and I mean whatever that does not match the whitelist, then block it. Or you can set up an HTML5 messaging channels to interact with Windows. But if you choose the third option, you gotta make sure, because there's a lot of vulnerabilities that if the channel that you set up is not secure, then you can abuse this, attack with court-side scripting in some cases, and etc. So these would be the ways to deal with this. I really advise using the first one. Just remove the callback parameter, set it in the server side, and that's pretty much it. Or the whitelisting is quite good as well. Okay, so thank you very much for being here and for listening to this talk. And this is the time, like, if you have any questions, feel free to ask me. If you have, like, if you want to use the generators and that and all that, everything is online, so you can use it. Feel free, and go ahead if you have questions.
Any questions from the floor? Or maybe off the floor, you'll be around for the whole day today, and you'll be joining the party as well afterwards?
Yes.
Excellent. So, well, you know how to reach him then. Thank you very much.
Thank you.